Everyone, welcome to Chapter 8, Theory. Let's see what we're taking a look at. So, many learning objectives, but really the bottom line is we're going to take a look at risk and reward. And we'll calculate two ways of calculating risk, and we'll discuss how it relates to reward. Now remember, a lot of calculations will be explained more thoroughly in the homework questions, so here we will discuss more of the theory. Let's begin with returns. So when we talk about risk and reward, we are referring to our returns in terms of reward. Okay, so we have to calculate that and understand whether or not it's valuable or profitable in terms of our investment. So when we talk about reward or returns in regards to an actual dollar amount, we see our dollar is our profit or loss equals our ending value plus distributions minus original cost. Our rate of return is our that profit or loss divided by our original cost. So here we have another way of looking at it is our holding period rate. Okay, so if we invest and we have a certain time where that investment is being made, that's considered our holding period. And then when we sell that investment, that would be the end of it. So that's why we see our ending price, okay? And our distributions are any dividends or any income that we're receiving because of that investment during our holding period. We're going to subtract the beginning price, or the price that we paid for it, divided by the beginning price. And either two of these are similar, and you'll get a holding period rate. But ultimately, again, it's our profit divided by our costs. Here's a quick example here. So we want to calculate dollar versus and percent returns. So if Joe bought coins for $1,000 and sold 4 months later for $1,200, okay, so that's Joe. We have Jane. She bought 100 shares of a stock for $10 and sold 2 years later for $12 per share. She also received dividends of 50 cents per share for the year. So we have to calculate the dollar profit and percent return. So if we use that equation, again, we have ending value minus original cost. So that's Joe. Remember, he bought it for $1,000, sold it for $1,200. So that's his dollar profits, $200. Okay, and again, if we divide that $200 by 1,000, we have a 20% holding period rate. If you look at Jane's dollar profit, we have to also add those distributions. So that's the 50 cents. Okay, and we subtract that. Remember, the original 100 shares at $10. That's the original cost. Finally, we get $250 and 25%. Now, the only challenge with that is if you take a look at these two examples, one was over a shorter period of time. Okay, so this was for 4 months versus 2 years. So it's hard to compare whether or not is this a better return versus Joe versus Jane because it wasn't annualized. So that's why we have to talk about converting holding period returns into annual returns. Okay, so again, if we recall, we can use our annual percent rate or even our effective annual rate to convert it, and then we can actually compare appropriately where we have two consistent annual rates. So if we look back at Joe's example, okay, we have that 20% over the 4 months, and then Jane's HPR is 25% over 2 years. We can't necessarily conclude that Jane's investment was better. We have to actually do the math, okay? And again, don't worry too much about the actual calculations, but if we look at our, let's say, compare APRs, okay, so Joe's APR is 60% and Jane's APR is 12.5%. Okay, so actually Joe's investment is better on an annual basis. However, sometimes it may not be realistic to assume that Joe is going to consistently make that much money on an annual basis. Let's take a look at an example here. So, for instance, let's say you buy a share of stock for $2 and sell it a week later for $2.50. Okay, so if you actually do the math, we'll see that the APR is 1,300 percent, or look at even the effective annual rate, a ridiculous amount. Okay, so again, because this assumption mathematically is that you're going to make that 50 cents every week, that additional profit, which isn't always realistic. Okay, so we have to consider that as well. Let's now move on to risk. Okay, so when we're dealing with risk, we're ultimately talking about uncertainty. Okay, so the more uncertainty, the more risk, there's more potential for loss. And that's something we definitely need to take in consideration when we're talking about, our returns and investments. So here, this is 4 examples. Okay, so we're taking a look. First is the treasury bills. Then we have long-term government bonds, large company stocks, and small company stocks. So in terms of risk, this is going to help us see, compare the frequency, okay? And it's actually going to help us start to understand the relationship between returns and risk. So if we look at our treasury bills, and all this means is we can see that our returns here, most of the returns, okay, so the frequency, okay, in this case we have the majority of returns are from 4 to 6 return rate, okay, which isn't too high, but it's the most consistent. And you can see actually it's less spread amongst the mean here. Whereas when we keep on moving to even long-term government bonds, we see that there's less consistency. Okay, so you can see there's a greater spread of frequency, and certainly if you move down to small company stocks, okay, you can see that the frequency is varied. But what's also important to note out is that the rates of returns can be very, very high. Okay, so in this case, rates of returns can go over 40%. Okay, but also they can dip down below 10%. Okay, so if you compare the small stocks versus the treasury bills, you can see here that these are a much safer investment because there's no circumstance where you would lose any returns. Okay, they're all positive returns, where here you actually have negative returns. However, again, take a look at the reward can be higher here. Okay, so we're starting to see the connection between returns and risk. So again, a little summary here. Okay, so the small company stocks, they earn the highest average over the 5 decades, but they also had the greatest variability. Okay, so that wider range. So where you compare to the 3-month treasury bills, okay, they own the lowest average. Okay, so their returns weren't very high, but they also were the less riskiest because they had less variability. So again, we can see that returns and risk are positively related. Now, in terms of measuring returns or risk specifically, we can start with using standard deviation of a measure of risk. Okay, and really this is just how much variance, how far away it is from the mean. And I know you're taking a statistics class as well, so hopefully this will be reinforced as well. But we'll take a look at some examples in just one moment. Just remember, the larger the variance, the greater the variability. Okay, so going back to our original examples of those 4 investments, when there's more variability, there's a higher standard deviation, which implies more risk. Okay. So here we have an example. Again, we have the annual returns associated with large company stocks. Okay, we're going to calculate the variance and standard deviations of those returns. So again, we'll spend more time doing this in Excel, but here we see we've calculated the variance and the standard deviation. Basically, we have our returns and we have the mean, and we're going to subtract the difference in the mean, which in other words, difference squared. We're going to sum that up, and then use this formulas here to get the variance and the standard deviation. Now, let's just talk about it in general. When we talk about normal distribution, in standard deviation. We'll use this example where the mean is 0, okay, the standard deviation is 1. So ultimately what we see is that this between one standard deviation, okay, plus or minus, okay, so basically all this area here, okay, 68% of the probability lies in that area, okay. If we go to another standard deviation, okay, then we have about 95% of all of this area is our probability. And finally, we go to 3 standard deviations, it's 99%, okay, probability. But bottom line is, the greater the standard deviation, okay, the more risk, the more variance in terms of the results. Whereas we have a smaller standard deviation, we have less risky performance. So let's take a look at it a little bit more specifically. So if we have a mean of 10%, okay, a standard deviation of 12%, then we can determine that 68%, okay, is going to be, if we add them together, we have our 22%, and if we subtract them, we have our -2, okay? So in other words, this area here will be that one standard deviation, okay? So we have, in other words, we know that we have returns between -2% and 22%. Now, if the standard deviation was smaller, okay, imagine the standard deviation was 1 or something, then the variance, it would be 10 plus 1, and then 10 minus 1. So it would lie between 11 and 9%. Okay, so you can see when we increase the standard deviation, the probability increases too. It spreads out. Okay, and then we move on to 2 standard deviations. We're doubling that standard deviation. So in this case, we have 12%, becomes 24%. Okay, so in other words, we're going 10 plus 24 now, and we're also 10 minus 24. So when we're dealing with our 2 standard deviations at 95%, we're looking at a greater range of -14 and 34%. Okay, so it's that area here. Okay, so again, bottom line is smaller standard deviation, smaller range, smaller volatility, whereas a greater standard deviation means that there's less certainty, more volatility. So when going back to comparing those 4 investments, right? So if we remember from the histogram, we saw that there was it was the 3-month Treasury bill. It had the lower average return, okay? But if you look, it has a smaller standard deviation, smaller variance, okay? So in other words, we have less risk, okay? And you can see, remember we discussed there was no negative returns, okay? They're all positive returns. Of course, when we move closer to this area here, the average return is actually higher. However, there's also a much greater variance in standard deviation. So what does that mean? Well, that means that there are actually, in this case, we have the most, we have a lot of negative returns here, also positive returns. So there's a bigger spectrum of variance. Even though we might have some more negative returns here, the uncertainty is higher with small company stocks. And again, you get a reward for that uncertainty. So in other words, higher risk means higher reward potential, because you can see here the average return is much higher. And we can look at it even from here. Okay, so if you look at it, risk in this case, we can see again that those small bonds or small company stocks has the highest risk, but also has the highest return.